Consuelo athletes. Okay, you got to stick with me on this one. I'm going to try and take it slowly, but this is one you really have to pay attention to. At first, I'm going to just show you what it looks like, and you're going to go, what the heck did he just do? And then I'm going to go back and do it slowly. Okay, this is called synthetic division. It's just a shortcut to division. I'm not going to go into all the theory of why this works, but I just want to say this. You have to know when to do something. I often say it's not enough to know how to do something. You have to know when you do it. Okay? So the first thing I want to talk about is when can you do this? And the only time you can do this is if the divisor has the two following things. It has, first of all, the leading coefficient of 1. So this right here. Okay, the variable has a leading coefficient of 1, and it's got a constant. Okay? Now, the constant, it's not that big of a deal. That'll just kind of happen. But it's got to have a leading coefficient of 1, and the variable exponent must be 1. So since there's no leading coefficient explicitly written in this problem, its coefficient is 1, and since there's no exponent written, it's understood to be 1 on the variable. Okay, so let's take a look at these things. And the first thing we want to look at is, can we do it or can't we? So let's take a look at number 1. And these are basically, if I'm not mistaken, the exact same problems we did last time, by long division. Okay, so number 1, you can't do this. Why not? Because the leading coefficient isn't 1. So don't try and do this by synthetic division. It just doesn't work. Okay, the second one. Okay, we can do this by synthetic division because the leading coefficient of the divisor is 1 and the exponent's 1. Okay, again, remember, this is the divisor. Okay, so this is what you're going to do. First of all, I'm going to just show you the setup. Basically, what synthetic division is division where you don't have the variables. Okay, we're going to kind of take the variables out of the problem. So what we're going to do is this. We're going to take the opposite of that number and stick it in a box. So notice the numbers, it's x minus 3, so we're going to stick a 3 in a box, okay? If it was x plus 3, we'd stick negative 3 there. So it has to be the opposite of whatever that is. Next, we're going to take all the coefficients and write them down, leaving a space between them, okay, without the variables. So the first one's 1, the next one's negative 3, the next one's 7, the next one's 1, and the next one's negative 10. Okay, and then leave a space underneath them. Now, if we went back and looked at long division, what are the two operations you perform? You multiply and divide, multiply and divide, multiply and divide. Sorry, that is wrong. You multiply and subtract. I apologize. You multiply and subtract. You multiply and subtract. You multiply and subtract. Okay, well, what are the two operations we're going to perform here? We're going to add, then multiply. Add, then multiply. Add, then multiply. And we're just going to keep doing that. Now, before I do any of this, though, okay, I have to show you something. Don't write any of the rest of, for a while, don't write anything down. I'm going to do it in this kind of open space here. Okay, but don't write this down. Just listen. Let's say I did this problem by long division. Just any problem. It doesn't really matter. And let's say it's x to the, third plus x to the second plus 7, whatever. It doesn't really matter what the rest of it is. And I'm going to divide by, let's say, x plus 4. Okay, remember what we do in long division. What times this gives me that? In this case, it would be x to the second. Notice it's 1 less. Since this is x to the first, and for synthetic division, it always, and again, don't write any of this down yet. Remember, the degree always has to be 1. Okay? So x squared times x to the first would give us x to the third. Notice this is 1 less than the degree of the dividend. Okay, fine. Well, what if this just happened to be, x to the fifth? What times x to the first would give you x to the fifth? Well, it would be x to the fourth. Notice again, the degree of this is 1 less than the degree of that. Okay? Well, what if it just happened to be, I don't know, x to the 50th? What would this be? This would be what times x to the first gives us x to the 50th, and it'd be x to the 49th, which notice is 1 less than that. And why is it 1 less than that? Because the degree of the divisor is 1. So basically what I'm saying is, for the exponents, what can I add to the 1 to get 50? And it'd be 49. I don't care what the exponent is here on the dividend. No matter what it is, let's say it's the word dog. Well, what times x to the first would give us x to the dog power? It'd be x to the dog minus 1. It'll always be 1 less than the dividend exponent, the leading term in the dividend. Okay? So no matter what I get, what I am given, the degree of the quotient will always be, and this is the quotient, the degree of the quotient will always be 1 less than the degree of the dividend. Okay, now I'm going to get rid of all this, but you have to remember that. Okay, because at the end, we're going to have to put the variables back in, and we're going to have to put the variables back in with the correct exponents. Okay, so just watch. Don't write any of this down. This is not going to make any sense to you. I just want to show you what it's going to look like when you really do this. Okay, but don't write any of this down. Just kind of watch real quick. Okay, what are we going to do? We're going to add, and 1 and nothing gives us 1, then multiply. Add, then multiply. Add, then multiply. Add, then multiply. And then add. Now, at this point, we're going to put back in the variables. Well, remember, the quotient has, and by the way, I realize what I just did. You're not going to understand it. Okay, I'll go back and redo it slowly. Okay. Remember the degree of the exponent for the quotient is 1 less than the original problem. Well, the original problem is an x to the 4th. So this will be 1x to the 3rd plus 0x, and then we just go down by 1s. X squared, x, 22. Now what's this? This last thing is the remainder. And if you go and compare this to when we did it by long division, it's the same answer, but you'll get it a heck of a lot faster. Now, let me get rid of all of this and let's go through it, at a more reasonable, speed. Okay? Okay. So, what you're going to do is add the 1 and what's right below it. Well, right below it is nothing, so you get 1. Then you take that number and you multiply it by the number in the box. And you get 3. And by the way, you don't need to write all this. I mean, for this one, you should probably write it down. But notice, when I did it before, I didn't write down all these arrows and everything. It's just faster if you don't. Then you add these two numbers, the -3 and the 3, and you get 0. Then you take that number and you multiply it by the number in the box, and you get 0. Then you add the 7 and the 0. Then you take that number and you multiply it by the number in the box. Then you add the 1 and the 21. Then you take that number and multiply it by the number in the box. And again, why this works, I'm not going to go into all the theory. And then you add those two and you get 56. That's how you get those numbers. So you take this number and you add it to the number that's underneath it, and right now there's no number underneath it, so you get 1. Then you take that number, multiply it by the number in the box, and you get the 3. Then you add the negative 3 and the number that's underneath it. Negative 3 and 3 is 0. And I know this still seems weird, but, and then you take that number and you multiply it by the number in the box and you get 0. Then you take 7 and you add it to the number that's underneath it. And 7 and 0 gives you 7. Then you take that number and multiply it by the number in the box and get 21. Then you take the 1 and add it to the number underneath it. And you get 22. Then take that number and multiply it by the number in the box to get 66. Then you take the negative 10 and add it to the number underneath it. Okay? Now we have to put the variables back into the problem. Again, since the original problem was x to the 4th, we're going to start with a number just 1 less than that, so we're going to start with x to the 3rd. So we get 1x to the 3rd plus 0x squared. We don't need to include that, right? Normally it would be like plus 0x squared, but what's 0x squared? It's 0. So I'm not going to bother putting that. Normally there'll be a number there and you'd include it. And then, so it's 1x to the 3rd plus 0x squared plus 7x plus 22. And now, what's that last number? That last number is the remainder. So we put 56 over the divisor, which is x minus 3. And like I say, if you go back and look at the way we did it before, you get the exact same thing. Okay? All right. Let's take a look at another problem. Okay. So again, I would recommend you kind of try this on your own and then come back and watch the rest of the video. Okay. So I'm assuming you've tried it on your own. So what happens? We take the opposite of that. So we put negative 1 in the box. And then we put every coefficient. Now, the thing you got to be careful of here is notice, this is x to the 4th and this is x squared. Just like in long division, you have to have every exponent represented. So notice we're missing the x to the 3rd. So we've got to include the 0x to the 3rd. So we've got 2. Then 0x to the 3rd, then negative 4x squared, then negative 5x, and 1. Okay, then what are we going to do? We're going to add, then multiply, add, then multiply, add, then multiply, add, then multiply. Again, I suggest you try and do this yourself. It's not going to help you to just keep watching me do stuff. So I suggest you stop the video, try it on your own, and then start it up again. But I'm gonna start doing it right now. And this is what it looks like. I'm not gonna, go through it slowly here. If you need to go through it slowly, go through the previous one okay. So we're gonna add, then multiply. Add, then multiply. Add, then multiply. Add, then multiply, and add. And now, because the original one was x to the 4th, this is going to be x to the 3rd. So it's 2x to the 3rd minus 2x squared minus 2x minus 3 plus, that's the remainder. So it's 4 over x plus 1. Okay. Number 4, I can't do this. Why? Not because of anything in the dividend. The dividend's not the problem. There never is. But the divisor doesn't have an exponent of 1. The leading term in the divisor doesn't have an exponent of 1. So this you can only do by long division, which we did in the last video. Okay. Let's take a look at this one. Again, we're going to take the opposite of this number. And then we've got 3x to the 4th minus 17x cubed plus 12x squared plus 0x, because we're missing the x term here, and then minus 7. Okay. Now, what do we do? Add, then multiply. Add, then multiply. So 3 and nothing gives us 3. 5 times 3 is 15. Then add. And again, I suggest you do this on your own. Then multiply. Then add. Then multiply. Then add. Then multiply. And then add. Okay? And since the original problem was x to the fourth, we're going to start with x to the third. So it's 3x to the third minus 2x squared plus 2x plus 10. And then the remainder is 43 all over x minus 5. Okay? So that's really about it. Now, there's just one last thing I want to mention, though. Last video I talked, or it might have been in the first one, I can't remember, on division. No, it was the last one. I mentioned that the only time the divisor is a factor of the dividend is if the remainder is 0. So let's take a look at number 2. Is x minus 3 a factor of x to the fourth minus 3x cubed plus 7x squared plus x minus 10? In other words, if I factored the dividend, would x minus 3 be one of the factors? No, it's not. How do I know that? Because the remainder isn't 0. If the remainder had been 0, then I would know x minus 3 is a factor of the dividend, but it's not. Let's take a look at the next one. If I factored 2x to the fourth minus 4x squared minus 5x plus 1, would x plus 1 be one of those factors? No, I know it's not going to be. Why? Because the remainder is 4 and not 0. Remember, the only time the divisor is going to be a factor of the dividend is if the remainder is 0. And I could say the same thing for number 5 here. Okay? So take it slowly. I suggest maybe you watch the first example, because that's the only one I went through slowly several times. Hopefully you tried it on your own, because just watching me do stuff really isn't going to do you any good. Anyway, if you can do stuff by synthetic division, I would recommend you do it. Again, remember though, you can't do everything by synthetic division. You have to, first of all, the divisor has to have a leading coefficient of 1 and an exponent of 1. For like, if you look at number 4 here, I couldn't do that by synthetic division. Okay, hope that helps. Have a good day, everybody.